Alright, so for this video, we are going to see how are we going to use the compound angle formula, okay, to solve the equation that involve cos and sine pattern. Alright, so maybe I will discuss example 18 with you, and then you try example 19 on your own because these two examples are quite similar. Okay? Alright, so maybe okay, so we can try example 18 now. So if you look at example 18, first question, they want you to express 4 cos theta plus 3 sine theta in this form. Okay, and of course they will tell you that the R is always positive and also the alpha is always in the first quadrant, and they want you to give alpha correct to 4 decimal places. Right, so when you want to do this, generally what is what is the first step? You need to maybe copy the question first. So they actually want you to change this, become R cos theta minus alpha. Okay, so first of all, you will see that again, okay, they already put the cos theta as a first term, and therefore they want you to change it, become the cos compound angle. So there should be no issue. All right, and the second thing is you will see that you are having a plus sign outside here when you expand it, and then before you expand in the compound angle formula, it should be the opposite sign, so which is negative. All right, so everything is nicely done, right? Nicely requested by the questioner. You don't need to do any adjustment. Okay, so to get the value for R and also the alpha, very straightforward. You just need to apply the formula. So for this case, you should know that A is the 4 and B is the 3. All right, and how to get the R? R is A squared plus B squared, which is equals to 4 squared plus 3 squared, and you will get a 5. This is very, very straightforward. All right, and then after that, to get the A, it is tangent inverse B over A. So B over A is 3 over 4. And try to keep it to 4 decimal places. That's the first thing. And also, if you look at the requirement here, they actually want you to keep your answer for alpha in terms of radian. In radian, all right? Therefore, you should get 0.6. Sorry, please wait me for a while because I think I didn't put it in 4 decimal places. Alright, so if I want to get the 4 decimal places for this part, what is the answer that you should have? 6435. 6435. So make sure that you follow what question 1. Alright, so since you're having R and also alpha already, therefore you can rewrite it again. So your equation here, your expression here, 4 cos theta plus 3 sin theta can be written as 5 cos theta minus 0.6435. Alright, so this is the first part of the answer. So actually it is very straightforward that if let's say you know the small details about how to change it become this pattern. Alright, okay. So we are done with part 1. Then now continue to part number 2. Alright, so for part number 2, what they want? So they ask you to solve the equation, okay, 4 cos theta plus 3 sin theta equals to 2. And then your theta must be in 0 from 0 until 2 pi. Okay, so if you look at this question here, like what I told you just now, when it is equal to 2 equal to any number, right, for this pattern of the question, you cannot solve it by changing it into tangent. So you definitely need to change it, become a compound angle formula. Okay, so by using the answer in the first part, you are now going to use 5 cos theta minus 0.6435 and you let it equals to 2. And from here, you continue to solve the equation and get the answer. Right, so again, first step is you move the 5 over, all right, which is equals to 2 over 5. All right, then after that, you try to take the basic angle. Okay, so for the basic angle that we have, again, it is in radian. So you should have 1.159 279,481. Alright, so usually for me, I will keep it longer in my steps. And then final steps only, I try to simplify it. If you're lazy, then try to keep your answer at least for 4 to 5 decimal places. Because the alpha here, they're asking you for 4 decimal places. Alright, so when you're solving all the solution for your steps, try to keep it at least 4 or 5. Follow what they want here first. Okay? Alright, so the basic angle is 1.1592, blah, 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 blah. Okay. Therefore, to get the answer for the 1, 2, 3, 4 quadrant, quadrant 1, 2, 3, 4, of course, you need to go through the quadrant, all right? So what they want is cos positive. So for cos positive, generally, it should be first quadrant and also the last quadrant, right? Okay, so for the first quadrant, you want the answer for first quadrant, which is 1.159279,481. You also want the answer from fourth quadrant, so the answer should be 5.123905826. So maybe you will ask me how I get these two answers. So again, first quadrant want the answer is straight away the basic angle. And then for the last quadrant, to get the answer, you need to take 2 pi minus basic angle. So all this knowledge again, we learned before. So if you forget how to do it, refer back to your AS syllabus one more time. All right, the process is exactly the same. Okay, and after that, how can you get the final answer for the data? So you need to bring the negative 0.6435 over. Right, so when you bring it over, you can simplify your final answer into the 3 significant figure. So if you didn't do any careless mistake, you should get 1.80 and also 5.77 as your final answer. Alright, so the final answer should be still in the 3 significant figure. Okay, they only request for alpha in 4 decimal places only, but they didn't mention anything about the final answer. So standard, you need to keep it in 3 significant figures. Alright, so this is what you have for example 18. So you can see that actually for this, it is hard because for first part, you just straight away apply the formula, which is very, very straightforward. And after that, you just need to know how to substitute the compound angle formula and try to solve it. So the solving part, all this, right, you already learned it before in AS level. So I hope that there's no problem for you to get the answer. Okay, so of course, this is one of the easier questions. They got something harder or more complicated one. Okay, but generally, the idea is more or less that. Okay, so for example, 19, I will want you to try out on your own. Okay, so I will give you only the final answer. For first part of example 19, you should get the answer like this, 25. And then sine theta minus 16.26 degree. Alright, and after that, they want you to find the smallest positive value of theta that's satisfying this equation. Okay, it is not hard also. The answer that you get should be theta equals to 59.1. Right, so please try this out on your own, and then if you cannot get an answer, please let me know again. Alright. Okay, proceed to the next example, which is also the very last example for our chapter 3. Okay, so first part. How to solve the first part? It is a bit complicated, but actually it is not hard. Okay, so first they want you to expand this one. Okay, so you just try to follow the instruction first. Okay, so expand cos x plus 45 degree. So when you want to expand cos x plus 45, you have cos x cos 45 minus sine x sine 45. Alright, and what's the value for cos 45? Square root 2 over 2. And then you have cos x here. What's the sine 45? Square root 2 over 2 sine x. Okay, so after you expand it, what they want? They want you to express this whole thing, okay, in this pattern. Alright, so now we start the second stage here. Alright, so they want you to express cos x plus 45 minus square root 2 sine x and they would want to let it equal to r cos x plus alpha. Okay, so please take note on this because don't be tricked by this question. Don't, okay, when you look at this one, you say, oh, first term is a cos, therefore you change it become the cos. So you will thought that A is a 1, so you cannot use that, right? When you want to apply and change it become the triangle formula, right? You have to make sure that you are having the pattern like cos x, something cos x minus something sine x. Okay, must be the x, cannot be x plus 45. Okay, so don't get tricked up because of this. All right, so if you want to change this, become the compound angle formula, generally you need to apply the expansion for what you have just now. Okay, so I will bring this over here, and therefore I'm having square root 2 over 2 cos x minus square root 2 over 2 sine x, then minus square root 2 sine x again, and I will get r cos x plus alpha. Okay, all right, then now let us continue. So the cos x is cos x, no problem at all, right? So before I continue, maybe I just put a small note here so that you know that I actually take it from this part. Okay, then now if you look at the sine x term, right, so for this green color part, if you don't know how to simplify it, okay, I'll just let you know that you assume square root 2 sine x is equals to an apple. So if you look at the equation here, negative, so you're having negative half apple minus 1 apple, and therefore you are having negative 3 over 2 apple. So when you simplify it, you will get actually negative 3 over 2 square root 2 sine x, and equals to r cos x plus alpha. Alright, so I will make sure that I'm putting it in the correct formulas. A cos x plus b sine x equals to r cos x plus alpha. Okay, then when you simplify everything under these steps, then only you can find out the value for r and also find the value of a. Okay, and then if you look at the question again, they actually want you to keep alpha in degree, and then also until 4 significant figures. For r, sorry, r until 4 significant figure, and also the alpha for 2 decimal places. So you have to follow all the requirements given in the question. Okay, then now when you simplify everything until here, then you should know what's the value for a. This is the a. All right, so what's the value for b? This whole thing is the b. Okay, then continue from here. Okay, so what is the r? So r is equals to square root 2 over 2 square plus 3 square root 2 over 2 and then square. Alright, so if you didn't do any careless mistake, you have a square root 5 here, and because they want 4 significant figure, therefore you should get 2.236 for the r. And then to get alpha, very easy also, you need to consider tangent inverse b over a. So again, please take note that the b, right, we only take the positive value. We will not refer to the sign, negative. Okay, so I'm having 3 square root 2 over 2 divided by square root 2 over 2. Okay, and press calculator, you will get 71.57 degrees. Okay, therefore, cos x plus 45 degree minus square root 2 sine x, it should be equals to 2.236 cos x plus alpha. Okay, so the beginning part is a bit complicated because of you need to add everything as substitute and rephrase. But generally, again, when you want to find the value for I and also alpha, it is actually very simple, very straightforward. Okay, so this is what we have for part number 1. Okay, then if you have a look for part number 2, okay, so for part number 2, what they want actually, so they are asking for, okay, solve the equation for this one equals to 2 for 0 until 360 for the value of x. Okay, so for part number 2, I think I will want to leave it for you to try out on your own. Okay, so how to try it for part number 2? Okay, so since you already get this pattern in part 1, right? Okay, so that means what? That means you can straight away substitute this equation 2.236 cos x plus 71.57 degree, and you let it equals to 2. Okay, because this is what you showed just now, right, in the first part. So straight away substitute it, and then try to solve it yourself. Okay, so if you didn't do any careless mistake, right, the x that you get should be 261.9 degree and also 315.0 degree. Okay, so this part I will just leave it for you so that you figure out how to get it correctly. Alright, so generally you can see the pattern. Okay, so this example is slightly harder one because you need to explain the compound angle formula first. Only you rephrase it, then only you can get the R and alpha. Okay, but it is not hard actually because the process is there, right? To get the R and alpha straightforward again, just apply the formula. Okay, when you want to solve the equation, just substitute the equation that you found in part number 1. Okay, then you solve it out. So these techniques are all in AS level. You learn it in AS syllabus before. Okay, so this is what we have for our A2 trigo. Alright, so again, I believe that you learned most of the identity before. But this one I think is something new, right? If I'm not mistaken, this is something new. Okay, so you can see that for the exam style question, usually what they ask is like, first part they ask you to prove, second part usually they solve. Alright, and you need to use the result in first part to solve the second part. Okay, so again, please make sure that you try more questions, more puzzle question maybe, so that you actually understand how they ask you all these questions. Alright, you need to familiar with the style, exam style question. Okay, so here we ended our chapter 3 already. Okay, so very soon in the next video, we are going to start with our chapter 4, which involves the differentiation. Okay, right, so that's all for this video.